Hello, everyone. Welcome to another stream. We're continuing porting the FreeBSD kernel exploit to PS4. It's been a few days since I last streamed. I think last time we were here was Wednesday night, Thursday morning, basically, because it was another Australian special stream. Team Star was able to jump on for that one. You probably won't be able to jump on for this one because we're going earlier my time. Well, earlier in general. So he's going to be sleeping most likely. But yeah, we're going to continue. In between that stream and this one, I have made a few adjustments. Those who were at the end of the last stream might remember we were having some issues where WebKit was crashing when we were trying to do our run our kernel exploit because we were calling so many syscalls. I think I tallied it, and we were somewhere around like 400 syscalls would run or so, and then it would crash. That's due to the code execution method that was used on 5.05 for userland. For the 5.05 kernel exploit, it wasn't a problem, but for this one, it does seem to be an issue because we have to use syscalls a lot more in order to set up the exploit. So what I ended up doing was I took ChendoChap's ChendoChap did a newer userland exploit on 5.05 that used the same bug, but it used the code execution strategy that I put in place on 6.20, which was the vtable overwrite, and that tends to be a lot more stable with more syscalls. I'm not totally sure why. I haven't really dug into it, but it is. So I basically took the ChendoChap's 5.05 exploit, stripped out the old IP6 stuff, and I've retrofitted what we had into that. So that's what I've been up to. Today we're going to be continuing that, and hopefully we should be able to make it further into the exploit chain. So some people have been asking for progress. I would say currently we're about 1/3 of a way there on the kernel side. There's kind of 3 major phases with the exploit that I've implemented, which I should also bring up on stream. Actually, I should make a command for that too. I put the kernel exploit implementation in C out on GitHub gist or whatever it's called, however you're supposed to pronounce it. I should probably put that in a command, but unfortunately, I always let Z do that stuff, and I actually don't even remember where you go to add commands to the chat bot. So I don't even remember where that is. So maybe I'll just wait for Z to come by. I'll get him to add it in. I feel like a boomer sometimes when it comes to Twitch because like Z started handling that stuff, and where I've just been streaming, I was just like, okay, I'll let you do that, and yeah, I don't know if I can set that up, and no, because the other thing is too, I'm logged into my personal account for moderation, so I can't even access the dashboard easily. I can, but not easily, and anyway, I'll put it in chat for now. If Z comes around, I'll ask him to make it a command, but that's the exploit that I'm porting, essentially. I was about to go to sleep, but I had to come here to say hi. Hello, Blika. Thanks for dropping by. If you know what you don't know, if you know what you don't know is a good thing, you know what to learn. Yeah, I mean, honestly, it's just because I was, like, complacent and just letting Z do everything. So when he's not immediately available, it's kind of it hampers the shit out of me. Me as well, my eyes are falling. I appreciate you guys sacrificing your sleep to drop by. So yeah, this is the exploit reporting. There's kind of 3 main phases to it, right? We have the initial setup phase, which is triggering the bug and getting an overlap. We are at that stage on PS4. We do have an overlap, so that's good. So this, let's see, if I had to highlight, so my CPOC is 568 lines of code. I would say our WebKit exploit currently covers 326 to 472, right? So now we just have to get an overlap on a TCP socket pair, and then after that we have the race phase. So yeah, we're about 1/3 of the way there with the port. Today we'll try to take it to at least the second, like 2/3 of it done. I don't know if we'll get all the way to like getting the port to code execution, just because tonight is kind of a cram night. I have a few things I need to get done and a few other things I want to get done tonight. Because tomorrow is podcast day, the Day Zero podcast, so I have to read up on topics and get some of the final notes that I don't have yet for that. My FPGA came in today that I ordered, and I want to kind of play with that a bit, because that'll be a lot of fun, I think. And we got this stream to do, too, so bit of a packed night, but we'll, I wanted to fit a stream in, because it has been a few days, so. Alright, I was looking at PSP 3000 boot ROM. If the documented knowledge about Kirk is correct, I feel like it's trivial to exploit and run custom IPL. That sounds like it'd be fun. What kind of FPGA did you buy? I'll get a picture of it up, actually. Let me just get a, oh, I hate how Discord doesn't let you do that. Okay. It's a Digilent, and it runs an Artix chip. That is the FPGA that I got in today. So it's pretty cool. It's got these headers on the side that you can put some external peripherals that you can buy into. It's got a VGA. It's got a bunch of dip switches. It's got a 7-segment display. It's got a few like cool features on it that you can mess with. The chip itself, the Artix 7, is actually pretty decent. I think it's like 33,000 logic cells that are in it. So yeah, this is a very good board, and it wasn't too much. It was about $180 Canadian, which is pretty crazy because the other boards that I saw with this chip were like double that price or close to that. So yeah, this is a really cool board, and there's a few other people in the reverse engineering Discord that are also getting into FPGA stuff, and we're doing like a collaborative learning on it. So isn't Xilinx problematic with the open source stuff? I'm not aware of any issues with it. I know like setting up the tooling and stuff for these FPGA boards really sucks. Part of the reason I actually got an Artix chip board is because one of the other people that's learning FPGAs right now also has an Artix chip. So, I'm not going to have to go through like a different setup and go through the pain all by myself. I'll be able to kind of lean on him a little bit to get through some of the setup, which he says is like half the battle. So, check Discord PMs. Yeah, I mean, I'll check them in a second. I think I know what you DM'd me about. It's about the launching daemon stuff, right? Which you put out on Twitter. But I can check them in a second to make sure. Do you use FPGA to jailbreak the console in any form? So FPGAs have definitely been used in console hacking before. I'm pretty sure an FPGA was involved with dumping the Vita keys, like the glitch attack on food or whatever. I'm pretty sure one was also involved for the Switch. I think they used that for the glitch attack. PS4, to my knowledge, there hasn't been an attack that's used an FPGA. But part of that was because there was an attack that used a Teensy, which was the glitch attack, PS4 glitch or whatever it is, for doing the replay of the firmware to downgrade, or downgrade in air quotes. But because you didn't need a super high frequency, you didn't even need an FPGA. You could just run a Teensy to do that. FPGA is useful for doing like glitch attacks and stuff where you need a high performance thing. Like, you can do a lot of cool shit with FPGAs. You could do, like, glitch attacks, like mentioned. You could do, like, clock glitching or voltage glitching or whatever. One of the other things you could do is you could, like, snoop on an I2C bus, or you can snoop on maybe even a PCI Express bus, or tamper with it, inject your own data into those buses. There's a lot of cool stuff you can do with FPGAs. That said, I don't know how long it'll be until I'm actually at the state where I'd be able to do any of that stuff, because for those that don't know, with FPGAs, it's not like you can just write C and upload it to the chip and run it, right? With FPGAs, you're working with Verilog. It's a prototyping solution. It's usually what companies use to try to work out what they're going to implement an ASIC for. Because ASIC development is like stupid expensive, right? You're looking at millions of dollars to fabricate ASICs. So in order to make the development cost less insane, they use FPGAs for the prototyping. So you're at a lot lower of a level dealing with something like an FPGA. So the learning curve is pretty steep. But I think it'll be a fun thing to learn on, like, my downtime, because software has gotten a little bit boring. Like, I do software stuff a lot. That's pretty much, like, my main thing is doing software exploitation. So being able to take a break and do some hardware stuff too, or maybe not. I guess FPGA stuff isn't technically hardware, like, but being able to go into, like, a different area of what I'm not familiar with and learn something new, I think will be very fun and like a nice downtime sort of thing. So that's why I got the FPGA. I don't think I'll be pulling any attacks off with it soon, but we'll see. Maybe. Verilog is similar to C in my opinion. So I guess for FPGAs, it is like the C equivalent, kind of. It is like lower level though, in terms of, like, you don't have as many nice abstractions to work with. You can actually compile C for FPGA, but it's very inefficient. Yeah, I mean, then you kind of lose the benefit of what you're using the FPGA for, right? If you just compile C down to it. I know there are also, like, other languages built on top of Verilog. Like, there's sysverilog. I thought that was it, but I learned from those same people who are learning FPGA stuff, there is some other languages as well that are, like, higher level. I think, it's called BlueSpec, I think, is another one. Yeah, but there's a lot of fun stuff to learn there. Sorry, I went off on a tangent because, like, the FPGA stuff is kind of exciting. Something new to learn after, a couple years. Yeah, so let's get to the PS4 port. Oh, actually, I will quickly check your DM as well, because I did say I would do that. Oh, you wanted opinions on it. Okay. Sorry. After the stream, I will give the write-up a read, and if I have any feedback or whatever, I'll DM that to you. So I also wanted to see what yeah, okay. All right, cool. Yeah, I'll DM you at the end of the stream, and we'll go through that. Yeah, I wanted to see what tips you have on write-ups. Okay. You can make a shiny robot with it. Yeah. Do you think faster executions and less codes makes exploits more stable or less? It depends on the scenario that you're in, like your memory corruption scenario. If you have a racy aspect, like if you're exploiting a race condition, or if you have a race aspect in your exploit, like you need to reclaim memory really quickly. Oh, oh, thanks, Balika. I totally forgot that Z actually already set up that POC command. Or maybe Z did it sneakily. I don't know. I don't remember that being there, but my memory is shit sometimes, so maybe it was there all along and I just forgot. Yeah, I mean, if you need to win a race against even the system, like if you need to reclaim memory really quickly or something, then yes, your execution speed will matter, and having, like, especially a syscall, Syscalls are very expensive. I don't know if people really realize. It's in the title, so it is in the title, but I don't remember if I set that title or if Z did. Because he might have edited the title after the fact. But I think it was in there before. I think I just forgot. You know. The title was already set from the last stream, and I didn't, like, look at it or anything. I didn't even, like, reset the title, so... And I don't have the stream open directly, because I have code open, so... Yeah, good to know that there's a command there for it, though. Yeah, like, people don't realize how expensive syscalls can be in terms of execution time. If you're trying to win a race on, like, the memory allocator, like, okay, here's a situation where you are racing the system even if you're not exploiting a race condition. It's just the classical use after free, right? Which is essentially what we're doing actually in this exploit. You need to beat the system, because if you trigger a use after free, you trigger a free and you try to reclaim it, but your reclaim is too slow, something else can end up taking that, right? Your process can, or your thread can sleep, or it can just, some other process can run on a different CPU core, and it can steal that pointer away from you. Now, if it releases it back and you can get it still, then okay, maybe it's fine. But it could keep it and do something else with it, and then you're screwed, right? So you need to be quick in order to get that pointer back off the free list. So in the case of this exploit in particular, yes, the execution time does matter quite a bit, because we are triggering multiple use after frees, actually. We're triggering two. We're getting a use after free to get an overlap between a UDP socket and a TCP socket pair, and then we're triggering the use after free again to get the TCP socket pair and a corruption packet lined up. So it is pretty important. With with Sears Govi's exploit, it's important. With mine, it's a little bit more important on the third phase, because I'm inducing a more racy aspect than just the memory, too. So, yeah, I mean, that is actually one of the optimizations that we might resort to in the port, is we might make it so that we try to get the smallest execution time possible. And one way we can do that is, like, right now, you can see we're doing these chain.sys calls, right? What this is doing is it's creating a ROP chain, it's pushing the instructions in for running a syscall, and it's running the ROP chain, right? And each syscall is running it in its own ROP chain instance. So that's decently quick, but a way you could speed that up even more is to throw multiple syscalls on a single chain, like instruct it all preemptively, and then run the entire chain. Now it's even quicker than the way we're doing it right now. Now, what we're doing right now is sufficient for this phase. For the third phase, we might have to do that. We might have to combine multiple syscalls into one ROP chain. So that might be one of the micro optimizations that we do, precisely for that reason, so that we have the smaller execution time, more likely, higher chance of stability, I should say. All right. So we have overlap. Actually, okay, let's make sure that we're actually in a good place right now, because like I said, I did retrofit this code into what we had before. I did have to fix a lot of errors because ChendoChap did a few things differently with how he sets up like the ROP chain primitives and stuff. So I had to do some modifications. I think it should be good, but we'll double check. And side benefit of that is we'll have the beep counter going. So everyone loves the beep counter, and we'll get that incrementing, probably. So you guys should be able to see the terminal on screen for showing the kernel log of the PS4. We have that going over serial. So we'll be able to get all the information regardless. You know, we're not doing any networking shenanigans to get that. Fair warning for anybody who is interested in playing with this exploit or this bug. And on that note, actually, there's one more thing I meant to bring up at the beginning of the stream, and I just forgot to. I did finally update the repository for our stream progress. I know some people were asking me about that. I did put what we had with TeamStar up, and again, I will update this repository at the end of this stream as well. So anybody that's like wants to try it or try the different phases, do not do any kernel logging over a socket, because the vulnerability we're dealing with is in the networking subsystem. And we don't want any movement, or as little movement as possible, in the networking subsystem. If you pipe kernel log over socket, you are probably going to massively screw the stability of the exploit. Because you're going to have too much movement in the mbuff zone going on while you're trying to exploit it. So serial is really important for this exploit in particular. More so than previous exploits that have targeted the PS4. So yeah, you guys should be able to see that serial log. Let's go ahead and run the exploit real quick. So we're opening UDP sockets, and then we're going to trigger the double free and see if we get an overlap. Chendo Chap, always fixing for stuff. Yeah, his userland implementation of the code execution strategy, like, it's kind of funny that he discovered that, actually. I had no idea that the 6.20 code execution strategy would be more stable than what we had already on the earlier firmwares, but it was good he discovered that, because this is way nicer. You can already see in the log, like last week we'd have to run it a few times to even get to this stage, because it would crash because of so many syscalls being invoked. Here, we pretty consistently get to this point. I don't think I've once crashed before getting here, so, you know, that's good. We did trigger overlap, so we can see right here on index 6, we read in A. So for those who do not know exactly what's going on here, I'll walk you through it really quick. Basically, how we're detecting for overlap is we trigger the double free, and then we spray packets. And each packet gets sent to its own socket, right? So we have 64 UDP sockets, and on each one, we send a tagged packet which contains the index of that socket, right? So to UDP socket 0, we send 0. To UDP socket 1, we send 1, right? Pretty straightforward. Then when we go to read afterwards, what we're looking for is a discrepancy between the index and what gets read out. Because under normal circumstances, the index and the data will match. Like, you guys can see on the terminal right now, like, read I equals 3C, data equals 3C. That is what is expected behavior. But because of the double free, what will end up happening is one of the packets will get corrupted with the index of a packet that comes after it, and you'll have an overlap. So one packet will have the valid data that it's supposed to have, and one won't. In our case, actually, because we are triggering 2 use after freeze, there's actually 2 packets, or 4 packets that get messed up, but that's mostly irrelevant. We just care about the first set. So here's our log. So we got 0 is 0, 1 is 1, 2 is 2. When we get to 6, we get A, which means that the packet at hex A should also should be overlapping with the packet at 6, right? So that's where our overlap is. This is the second UAF that I talked about. Honestly, this doesn't even really matter. We might even prevent this from happening if we can do that, but I don't even think it's worth it necessarily. We should be able to handle that in the cleanup stage, but yeah, like, this is not even relevant. This couldn't happen, and that would be fine. So we can pretty consistently trigger the overlap. And like I said on some of our previous streams in the BSD kernel exploit, the overlap is more consistent on the PS4 than it was on the VM. Some who were watching during some of those streams might remember I was running the exploit a few times on the VM, and it'd be like, failed to find overlap, and then I'd have to run it again, right? And keep running it until I got it. On the PS4, I haven't found a time yet where we haven't gotten an overlap, so that's really good. We should take bets on who's more stable, Specs or Slurs. Yeah, I've always kind of said it will be interesting to compare them later on, so could be fun. All right. So we have the overlap triggering, so we'll move on to phase 2, which is getting an overlap with the TCP socket pair. So, as before, I do have my exploit POC in the in VS Code here for quick referencing. So this is what we're going to port right here, is this overlap. So we pop from from our first overlap, and then we reclaim it with a packet on the SCM writes message on the overlap. So let me just bring that up on the screen so I can reference that. And we'll get started here. 497 is where we're at. Okay, perfect. So in userland.js, what are we going to do? Well, first thing we're going to do is we're going to log that we're going to free overlap 1. And then we're going to do it. So we'll do chain.syscall, window.syscall names, sys recipe from. We're going to receive from spray socket UDP. Oh, actually, okay, there is one thing I forgot to do from the first phase before. And this was just because I was testing and we weren't this far yet where we needed it. So let's get rid of this. We'll have, so set up the variables here actually. Overlap 1. Oh, overlap 2. So we need to record the sockets that we have the overlap on, or else we won't know what sockets we have to receive on and send to, right? So the first overlap is going to be the index that we see the discrepancy. The second overlap is, oh, this should be above the debug log because I'm going to reference it. The second overlap is going to be the data that gets written in there because that's going to be the index, the data of the packet that gets overlapped, right? So that's going to be the p.read4 tag packet value. All right, so we have overlap 1, overlap 2. All right, so now that we have the overlaps recorded, we are good to continue on with the second phase. We're going to free the packet from overlap 1. And we are going to receive, let me just double check how much we receive here. Pop mbuff. Right, so this, how much was pop buff? Right, so pop buff was 37 integers, so we'll do 37 times 4. And, well, first we need to put where we're going to put that information. I think I allocated the buffer already for the pop data. It doesn't really matter because it's just trash. Like, we don't even care about it, what gets popped out. But we need to pass a valid pointer. It's going to default. I thought I had one set up, but I guess I don't. Okay, that's fine. We'll just allocate a new one. So we'll do var popbuff equals p.malloc, and we'll just do hex, or we'll do 37 times 4. I should probably, is it? Yeah, it is actually safe to do it at this phase. We're not in any race windows. So yeah, we will read it into popbuff and we'll read 37 integers. No flags, I don't think, because let me just check the pop and buff definition, but we don't need, okay, yeah, we'll specify the message don't wait flag, but we don't need the peak flag because we want to get it removed. We don't just want to peek it. All right, so now that we have that first overlap freed, we want to reclaim it. So we have that done. Now we need to overlap with the TCP socket pair. Now I need to double check, but I'm pretty sure I set up TCP socket pairs as well. Although I should check that that's still works, because I haven't tested this since we retrofitted. So, yeah, I'm going to print out those values. It will cost us one test, like one reboot, but I think it's worth it. I don't want to continue and end up with silly bugs because I thought something worked that didn't. All right. We are going to have to reboot, I think, because we triggered the double free. So I'll back out of the browser, but I'm almost certain it's going to crash. It'll probably crash when we re-enter the browser, right? No, make a fool out of me, of course. All right. I don't know why it's still alive. The PS4 should have died. But you know what? I'm going to restart it regardless because I don't want any lingering effects of that exploit run tainting our further ones. And it will probably crash when it gets to the double free anyway. So I will restart. Hopefully this restart should be quicker though. Now I am kind of at a crossroads. I don't know if I want to hit the beep counter because we technically didn't get any beeps, but we did restart. It's just that we did like a soft reboot. So beep counter increase or no? I don't know what to do. Oh wait. Actually, we will need to beep it at least once. So yeah, there we go. Problem avoided. It'll just be one beep instead of like 2 or 3 that we normally get with panics. I'm on 5.05 waiting for a really stable exploit. Oh, you mean you're like waiting before updating? I mean, unless you have a reason to update, I wouldn't even I wouldn't even like update from 5.05 if you don't need to. 5.05 is a really good firmware. Unless you're looking to play like newer games that have a higher min firmware, then I would stay where you're at. But that is a valid use case though, if you want to play like one of the newer single player games or whatever. So yeah, when the system reboots, we are going to run our exploit and make sure the TCP socket pairs are working. Actually, I do have to add the print code for that. I wanted to reboot the system, that way we could save a bit of time there. So, where do we set those up? Right here. Okay. So we'll do a var I0, I is less than 60. Yeah, 64. And then what we're gonna do is we're gonna do a debug log, sock pair, TCP sock pairs I0, TCP sock pairs I1. So what Teamstar decided to do here, and this was really smart, was when we were doing some of the pair programming on the last stream, we set up a TCP socket pair, and the way we record them into an array is we have a multi-dimensional array. So each index is the socket pair identifier, and then attached to that is an array of 2 elements, which has pair, like the first part of the pair and the second part of the pair. This is nicer than what I was doing in C, because we had to do like hacky math and shit. This will be a little bit cleaner. I really like this idea. It was smart. So we should be good to run another test. Actually, I'll just return early on this. Because opening the TCP socket pairs has nothing to do with the bug. So if we avoid triggering it, we don't need to reboot. So I just want to test that portion of the code. So we'll do an early return. So we're hoping to see a bunch of valid FDs for our socket pairs. So UDP sockets are good, but we already knew that. Yeah, these look good. These socket pair IDs, these look valid. Very good. All right, so we'll continue on with what we were doing. I kind of expected that would be the case, that they would be fine, but it's always good to, follow that old saying, trust but verify. Okay. So where we want to go from here is we want to spray SCM rights messages into the reclaim, or into the use after free slot. Creating these packets is a real pain in the ass, but we'll get it done. It'll be a good idea to create a function to do this, I think. So we'll do p.writeFD equals function. We're going to take a TCP socket. So sock, actually TCP sock, address, size, and a stack of file descriptors, which we also have to get, actually. I do have to open a bunch of file descriptors. That is one part of the setup that I haven't done yet, so we'll go back to that after I get this function implemented. So the function we're porting right now is this one, writeFD. Essentially what this function does is it creates a control message, or a C message. It sets it up with the SCM rights type and at the socket level. And it sets up the, like, a control message is basically a container. So you put in your message header information, like the length and the type and all that shit. And then after that comes your auxiliary data buffer. So whatever type you chose, that's where you put the data that's relevant to that. So what we're doing is we're creating a control message, setting up the header, and then we're writing our stack of file descriptors into the C message data. And then we're firing that into the kernel by sending it on the TCP socket pair that we have an overlap on using send message. Now, the thing that sucks is in C, I could kind of fall back on these macros that are defined in userland, or in libc, rather, like the C message space and stuff. I obviously don't have those in WebKit, so I'm going to have to port all that into, like, the raw pointer arithmetic, which is not going to be fun, but it does have to be done. So let's get into it. Let's get started. So the first thing we need to do is we need to set up a control union. And that just consists of the C message header, so that'll be fine. So we'll do C message header equals p.malloc. Here's where I'm going to have to start referencing the source, previously source, to get these sizes and offsets and stuff. So let's get that. Socket.h, is it? Yes, okay. I'll copy this into a comment, just so that it's readily available to us. Get rid of this stuff. All right. So this is going to be what is socklen t? I would imagine this has to be a int64, but let's double check. Oh, it's a uint32. Okay, I would have been wrong. Good thing I checked then. Okay. So that's going to be 4 bytes plus 4 bytes plus 4 bytes. Since this is not packed, this should be aligned to the 16-byte boundary, so we're going to have to add another 4, even though there's nothing following this. At least I'm pretty sure on that. Maybe I should verify that, just to be sure. Because technically what follows it is a... let me just look at something really quick. C message header. It's defined here. And 6. No, it's not here. This can be set up as a union with a char array. So I just want to make sure. Actually, if I look in my exploit, it's there too. C message space 253 times size of int. Oh. Actually, yeah, that won't work. That's annoying. Yeah, because I was thrown off by the union a little bit. So we have the C message header, but then we also have the data that precedes it right afterwards. For some reason, I thought the message header was. Let me just see what's tripping me up here. What does this macro do? C message first header. So it does a ternary statement here. If the message control length is greater than or equal to the size of the C message header struct, then it's going to point into the. Yeah, it's going to point into the message control field, and then if it's not, then it's just going to return null. Okay, I see. This is so weird that they use the macro like this. So if we reference our code real quick, control un.control. Yeah, so this is going to be the max size of the message, the C message header, which I believe is. Let me verify what it is here. We got 253 times 4. That's hex 3f4, and then we have a hex C header, because I was originally thinking that it would be, because it's not packed, there would be 4 bytes of padding, but since the control buffer that falls immediately after it is an array of characters, I don't think the padding will apply. So we have plus XC, that's, oh shit. Oh man. Really, I lost that? Ah, I'm in hex. Everything's falling apart. Plus 12. X400. I think that makes sense for the message size. That said, I can verify it in the previous DVM too if I need to. Oh, I see Z has shown up in chat. I'm just catching up on chat a little bit. I was kind of in a tunnel mode there. I still think 5.05 is most stable. So far, it is. Yeah. I mean, here's the thing. Even if you had the most stable exploit ever for 7.5 or whatever, the WebKit exploit is going to kill your stability there. So, honestly, stay on 5.05 if you can. Only worry about 7.5 or 7.55 or whatever if you couldn't get a system on a lower firmware, or if you need to, or if you want to be able to play like single player games that are newer. So my time is up, man. I need some rest. Wish you ended this soon. All right, man. Thanks for stopping by. Z's in there typing his, snide statements. I can read your mind as long as you type your thoughts into the chat box and hit enter. Telepathy is just out of bounds read. That's a pretty good one. I wasn't planning on using the VM at all. I actually have it powered down. But I think in this case, I am actually going to use it. I should use that corner. It'll just be easier, and it'll save some time that I could lose if I mess something up. So I'll take the safe route and just verify some of these values. Team Stars taught me well. Unprepared. I know. I didn't boot the VM before I started the stream. I'm such an awful person. But hey, you need to show off the full process. You need to show the FreeBSD boot process, I haven't applied that trick that Flats left in here either yet. He left a tip that you could like disable DHCP to quicken the boot, and I just haven't taken that into account. I will get to it. Probably after this stream, I will work on like doing that. But right now, I want to keep it focused on exploit stuff. And try not to tangent too much. So we got cleaned up.c. Right FD. Here we are. So I'm going to print out the message control len. Or we'll do that. Message control len. And then the other thing I think I'll print out is message equals %p, just so we know where the message is located. And then I also want to know where CMPTR points to. So we'll do that. So we'll do and message and CMPTR. All right, that should give us everything we need. The other thing I will do is, because I don't really want to deal with like crashing or anything. Actually, you know what? It doesn't even matter. So we'll do GCC spec cleaned up. And I need to pass the pthread flag. Wait. Wait, how does that make sense? I was just editing the exploit. Why is it telling me it's not there? Wait a minute. Oh, I forgot the .c. So stupid. Okay, there we go. A lot of people I've been talking to think that an exploit for 8.03 is going to be out by the end of this year. Oh my god, I'm so dumb. I forgot that in the VM that I'm... If I work directly in the VM in VMware, I can't scroll up because BSD is just garbage to work with from a user perspective. So I gotta SSH in when I do that. So annoying, dude. But it's fine. We can run it again. I totally like forgot about that nuance. It's been a few days since I've worked on the BSD VM, so yeah, I don't know who's thinking that there's going to be an 8.03 exploit by the end of the year. I mean, there could be. There could also not be. You know, it depends on. Depends on if a bug is found and exploited by then. I'm seeing a yikes dude in chat, and I'm wondering what it's for. Did I miss something? What's the yikes for? Let me SSH in really quick. 5. What is going on? Why is it telling me that I can't SSH into that? Okay, wait a second. Okay, I thought that looked wrong before the IP address. Okay. Alright, perfect. Alright, so let's run it again. This probably got deleted. I don't know. Yeah, it did. It did indeed. What the hell is this? Socket pair -1 to 0 has corruptible M buff. What? Oh, I guess because I added the logs in there, it's throwing off the timing. So it lost the race, and that's why it's so messed up. Yep, so the control len... So it is hex 408. So there must be padding involved. Let's get the message and the CM pointer out of the way. So the CM pointer points to... I don't feel like doing math in my head, so let's just copy it. Hex 420 bytes. CM pointer hex comes hex 420 bytes before CM PTR. Let me just verify that I'm printing out what I thought I was. Control length is, yeah, and then CM PTR is that. Okay. I'm just trying to think if that makes sense. Does that make sense? We allocate the message, and then we have the CM PTR at the first header into the message. And then that macro is doing this. Where's this at? I hate these macros. Okay. Yeah, so that makes sense because it's okay. I mean it's shitty, but it should let you scroll. Yeah, I could have used. I might have been able to use the scroll, or like the page up and page down commands or whatever. I just don't like working with BSD in the VM. I'll be honest with you, I hate it. SSHing in is just so much better. I can copy and paste and everything, whereas in the VM, I can't really do any of that. So, SSHing in is just a lot nicer for me. All right. So I will keep this on a separate screen as well, so I have it readily available. All right. So we'll just allocate the message in one big buffer. We'll just do like a p.malloc x1000. And actually, we can allocate that outside of the function as well, like that. Okay, so first up we have the message header, which actually I do have to pull as well, the structure for. See, message header and message header are a little bit different. This is going to be at 419. Oh, man. So many structures, so little time. Let me get this aligned properly. Okay. So the first part here, we'll do a write into the message control pointer. So we're going to do a p.write8 into message.add 32. Actually, I do have to get the offsets for this as well. Let's get rid of these comments because I'm going to use this stuff actually. So this is going to be at offset 0. This is going to be at offset 8. This is going to be at offset... it would be at hex C, but because it's a pointer, it's going to be aligned to a 16-byte, or an 8-byte boundary, sorry. This is going to be at 18, hex 18. This is going to be at... Again, it's going to have to align, so it's going to have to go to hex 20. This is going to be hex 28, and this is going to be hex 2C. Which leaves your overall size at hex 30. So we want to write into the first into the control pointer, so that's going to be at hex 20. And we are going to write in the address of the control buffer, which actually we will allocate that. Control. Yeah, we'll just call it control. And we'll write control into that. I think that works, right? Yeah, that'll work. Yep, so we're writing in the control pointer, and then for the control length, we need to write that in as well. So mesh.net32 hex 28, and we're going to write in God, did I write down the control length in the... I think I did, right? Just double check. I'm pretty sure I did, though. Yeah, it was hex 408. Yeah, that's right. All right, cool. That saves us a bit of time. Okay, that's the control message setup. Up next is the C message header. So that's going to point into the message buffer. Specifically, it's going to point... Let's think about this for a minute. Okay, there is something I'm a little bit confused on still. I don't know if it's because it's like... it's late or something. Why does the CM pointer... Why is that before the message? Am I crazy? Oh, wait a minute. Wait a minute. What? Oh. Just... Did I mess this up? Just double check this for a second. I might have had some bad pointer arithmetic in there. Now CM pointer is 0. What? It wasn't 0 before. Why is it 0 now? I didn't even edit that parameter. Yeah, okay. I don't understand that. I must have a bug that I'm not realizing here. The PS4 WebKit source is on their website. Do people compile it and run tests in VM instead of using PS4 to find exploits? As Z said in the chat, it's on the website. You will not be able to build it without fixing things. You'll get a bunch of compile errors if you try to build it. Most of the WebKit exploits that have come through, actually, I guess all the WebKit exploits that have come through so far on PS4 are just NDAs. They're, reports that were disclosed for Apple, and they got published after the disclosure deadline or whatever, and somebody tried the bug and made sure it worked on PS4 and then wrote an exploit for it. That's pretty much what WebKit histories look like for PS4. I don't, to my knowledge, I don't think a 0-day has really been used on PS4. Um, it's a 0-day in terms of it works on PS4, but it's not a WebKit 0-day. Because, yeah, those are expensive, dudes. Those are like WebKit 0-days, you're looking in the around the like $100,000 range for those types of bugs. So people aren't burning them on PS4 exploits. It's not worth it. Yeah, something's, I don't know why I'm having these issues with trying to dump these values. Like, I don't, yeah, I don't know why it was telling me that CMessage pointer was 0. That doesn't make any sense. Um, yeah, I don't see why it's so annoying. Because this looks correct to me. I don't understand. I'll run it again. Because I don't know if that was just a weird side effect of the exploit or something. CM pointer is still 0. I don't know, whatever, man. It's not right. Um, I'm probably making a stupid mistake that I'm just not spotting. I've got to be. I just want the value, like, values set up. But we're not having too much fun here trying to get that. No. I don't know why I don't know why it's saying CM pointer is 0. That's just not. That's just not true. There's no way it's null. That's not hold up. If it was null, we'd be getting crashes when it goes to write to it. So I don't know why it's telling me it's null, because it's not null. It's literally like it's writing to it right after that statement. I'm using the %p specifier, and CM pointer is actually a pointer, so I don't know why it's being like this. Yeah, I don't see what the problem is. I don't know why it's being so annoying. Um, I'm not modifying the message outside of what I already had. I just want to try something. I just want to see if this is what it is. I don't know why this would make a difference, but if I change that to an ampersand. Okay, I don't know why that makes a difference, if I'm being totally honest. The So basically all I changed was I changed the printf. And not even the part that should be relevant. Do I not have the cat in here anymore? I thought I had the cat. Oh, yeah, I do. There it is. Oh, really? As soon as I found it, too. Right? All I did was I changed this printf to use the address of operator on the first message. Now, like, that was kind of a bug. I tried removing that just to see, like, what would happen. Because message is a stack buffer, right? So that gets the address of it. That said, oh, god damn it, WSL. Oh, the right click. It's so annoying when it does this shit. Hold on. I'm not dealing with this shit anymore. I'm putting it in a blank text window. Should have done that in the first place, but I'm stubborn. Yeah, I mean, the first parameter for the printf shouldn't be affecting the latter parameter. That doesn't make sense. I don't know why it was doing that. Like changing this to this shouldn't be affecting what this value is. So, yeah, I don't know. Maybe it's the way the %p formatter works. If you pass something else, it corrupts it. I don't know. That's got to be it. It's got to be something specific to the p format specifier, but whatever. It's fine. I am still a little bit confused at why the like CM pointer points so far after the, or sorry, why it points before the message buffer. It should be pointing into the message buffer, as far as I can tell reading the macro. Or sorry, not into the message buffer, into the control buffer. Right? Because it's, yeah, whatever. I don't know. I'm kind of just getting hung up on it, but it was like kind of confusing me. Whatever, it's fine. We'll move on. Blame the calculator? Yeah, I'll blame the calculator. It's all the calculator's fault. All right, so we have the control buffer set up, or rather the message control. This is message. Up next is the CMPTR. So this is where we write into the control buffer. So we're gonna do a. Actually, we do have to get the offsets for these too. Get that out of the way. So this is going to be 0. This is going to be 8. And this is going to be hex C. And then this is going to be at hex 10, right? Just verify 0. That'll go 4 bytes. That'll take you to... Oh, sorry, did I do... Yeah, I did 8. I thought something might have been off there, because, yeah. Okay. So, yeah, we have the length, level, and type. And these are all 4 bytes. I'll verify that. I'm pretty sure I looked this up earlier, but we'll just be doubly sure. But I'm pretty sure this is 4 bytes. Yeah, UN32. All right. Cool. So, first field, the C message length, we're going to set that to, that's another macro that we're going to have to get. So, we'll get that in a minute. Dot add 32 0 x 0. And this is taking C message length. I'm pretty sure this is just like a fairly straightforward calculation. Yeah, it's doing in a line of the C message structure. This align macro. Line 50. E plus align bytes. Size of a register. Yeah, so this is aligning it to a 8-byte boundary. Because the register on AMD 64 is going to be 8 bytes. So earlier when I was saying like this data technically falls on hex C offset, this is going to be aligned to hex 10. So that's essentially what that's doing inside of that macro. And then it's just adding the length to that alignment. So, makes sense. So, this is going to be this is just going to be hex 10 plus 253 times the size of a file descriptor, which is an integer, which is 4 bytes. Next, we got to write the level, which is going to be at 0.4. I have to get the values for this as well. This is going to be SOL socket. I need the identifier for that. Oh, wow. Okay. That's the socket level, is XFFFF. Okay. So we'll get that. Var SOL socket. And the other one we need is SCM writes. That's actually probably in the same file. Yeah, it is. That's just hex 1. SCM writes 1. All right. So in here, we're going to write SOL socket. And then in the next one, control.add 32608, we're going to write SCM writes. There we go. Now we have the message and the control message set up. Next is just the data, which is taking the C message data field, which should, I believe, point to hex 10. I will verify that, but it should point to hex 10. Hello, everyone in chat. Welcome in if you're just joining us. Doing some porting, continuing from last stream. So this macro is casting the C message to an unsigned char, and then it's aligning it. Yeah, it's doing the same thing. Okay. So we're going to run this 253 times, and we're going to write control.add32 hex 10 plus I times 4, and we're going to write in the FD that gets passed in, so that's going to be FD's I. Okay, so breaking that down a little bit, the reason we're doing this little bit of math in the destination is we need to write into the data field. We can't smash the header we just set up, or that would be silly. And then each file descriptor is 4 bytes. That's why we're multiplying the iterator times 4. So it's basically just going to write every file descriptor in an array into that control buffer. So that's what we're doing there. Next thing we need to set up, actually, this doesn't even need to go here. We can do this up here. Some more message fields. We need to set up the name and name length. So the name is just going to be null. So message.add3200, and then we're going to write 0 for the name length as well, which is going to be 4 bytes. 8, 0. Okay. The other thing is the message IOV. We do have to send an IOVEC. I think just to get past the initial syscall checks. So we'll set up an IOVEC as well. Var IOV equals p.malloc. This is going to be really small. IOVECs are pretty simple data structures. I think on FreeBSD it is a little bit different than Linux, but if it is, it's not by much. Oh yeah, it's not even different. It's just a base and a length. So we have a 64-bit base and a 64-bit. Right? Just double check that. It's a void star and a size t. Size t is going to be 64 bits. Okay, cool. Right, so we're going to write into iov.add320. What we're going to write into there is going to be the address that we're given, and iov.add32608, and that's going to be SC. Although that doesn't even matter. We can pass that. Yeah, we can pass that from the thing, but it's just going to be 1 byte the way we use it. All right. We do need to set up the IOV pointer in the message, so let's do that real fast as well. That's going to be at message IOV, which is at hex 10. So we'll do p.write8 message.add32 hex 10. That's going to be set to the IOV address, and our IOV count is going to be 1. So that's going to be IOV len message.add32 hex 18. That's going to be 1. All right, we're just sending 1 IOVAC. It's literally just going to be 1 IOVAC of 1 character. It's pretty much irrelevant for the exploit. It's just to have something there, basically. I think that's everything. I think after that, we just do a send message. So we just do a chain.syscall. Syscall names sys send message. We're sending that to the TCP socket. We're sending the message address that we set up and 0 for flags. Okay, we should log the return value of this too, just to make sure that we have it done properly. Right, fd send message equals rb.toString16. Okay. The other thing I should probably do is dump the bytes of the... Well, we'll see if it works. And if it doesn't work, then we'll dump the bytes of the message. We'll leave that. So dump bytes, just so I have that written down so I don't forget it. Let me just look at the send message syscall page real quick, just to see what it can return. I'm going to send it without any file descriptor, or with a bunch of nonsense file descriptors, just to make sure that we're getting, like, we're even hitting the code properly, as like a sanity check. SCM. What? Okay. Oh, I think it's the send. It might be the send too that has the thing for that. I can just look at source though. So what we're looking for is UNP internalize. It's going to be at 1811. So if it gets a bunch of... Yeah, okay, so it throws ebadf if you pass in bad file descriptors. That makes sense. I thought they might not use that because usually, like, ebadf, that you'll also get that if your socket descriptor is bad that you give. So I thought they might have wanted to throw a different error to avoid clashing with that error node, but I guess they don't. They just throw ebadf. So, what we're expecting here is for this to fail and give us the ebadf descriptor, and then, yeah, if that works, we have a sanity check that we know things are. It should be hitting the code properly, basically, because we've already verified that the TCP socket is valid. In fact, I will do another login here real quick. Sys send message, kind of like what we did before, just to validate everything is correct. toString16 message 0, and that's going to be toString16. Well, do a 0x specifier because Teamstar gives me shit if I don't. All right, so we're just going to make sure that we're calling send message properly, and setting up the message properly. So we'll do p.writefd, TCP sock pair, TCP sock pairs 0. Yeah, we'll take the first one. Into that, we will write. Actually, I do have to set up a bar garbage equals 6, 8. We'll have to do that before the race. And we're just gonna write in like garbage something. Actually, what am I doing? Can't do that. I don't think. Maybe I can. I don't know. JavaScript. I'll just do it with the value I know will work. Right, so we have write FD, and then we have an address of garbage, and we're going to pass a size of 1. And we'll pass an empty array of file descriptors. Or actually, we'll pass an array of known to be bad file descriptors. So we'll do FDs. I equals 0. I is less than 253. FDs I equals. Okay, just bullshit file descriptors. Actually, we'll make it even more fun. Dead beef. All right. Let's give it a test. See if we get the behavior we expect. Oh, actually, let me bail out really quick. I do want to print out the errno. Errno equals 0x plus e.readDate errno. There we go. Now we'll be able to make sure that we're actually getting ebadf and not something else. Good morning, JinxCBX. Welcome in. Good morning, everyone who's joining. I know it's starting to peek into those hours of the when people are starting to wake up in some of the countries that we get in our streams sometimes. We're at 12:30 Eastern. Okay, so interestingly, we got a write FD that seemed to succeed, which is really messed up because we're passing a set of bad file descriptors, so I don't know why it's telling us that it's fine. That's really not what I was expecting. Because we specify the control address. So that should be getting passed in. The control size should be valid. Control un.control. I don't know why it's telling us that everything is fine. When I want things to work, they don't work. When I don't want things to work, they work. It's really weird. The IOV looks good. Like, it's hard to mess up the IOV. The message looks fine. There's no way this should be succeeding. It should be rejecting the stack of file pointers out of hand. Oh, wait a minute. What did it actually return? Send message returns 0. Is that correct? I think it's supposed to return... Yeah, it's supposed to return the number of characters sent. I'm pretty sure that's supposed to return 1 for the IOV length that we specified. So it's not erroring out, but it's also not sending them properly, which is kind of weird. We've got to be messing something up. 5:35 in UK. That's a bit early. You must be an early riser. I couldn't wake up at 5:30. I'm usually still awake at 5:30. I should go to bed at like 6 to 7. Well, that's not great. I've tried to fix it. Tried to go to bed earlier, but it's tough, man. Yeah, usually I'm awake at 5:35 my time, but I'm not waking up. I always wonder what it would be like to like wake up that early. I remember back in days when I used to like go to school and stuff, and I'd have to wake up at 7 a.m. There's a certain like air or ambience, I guess, that is so calm at like when you wake up at that time before before everyone's up and things are moving. Like, I remember I used to have to get up and go for a walk at like 7 a.m. and it was so peaceful. Those days are gone. Now I'm just a night owl. One day I'll get back to it, maybe. We'll see. Maybe one day I can do it again. Um, so I think what I'm gonna do is I'm going to SSH back into the VM and I'm gonna dump the message buffer and I'm gonna dump what I have on the WebKit side and see if there's any discrepancies because something is amiss. So exploit spec cleanup.c. Oh, okay. I probably have to re-upload the file. Which actually, I'm gonna edit it locally because I do lose the file quite often on the VM. Because basically, like, for those who haven't experienced it, usually if you run an application that crashes the operating system, one of the last things the operating system will do before dying is it'll delete the binary that caused that crash. And in a lot of cases, it'll delete the source file that was responsible, that was compiled into the file that caused the crash. I don't know why. It just does. I don't know if it's like a file system corruption thing or if it does it on purpose. But it's pretty common for it to just delete everything. So we'll go into writefd. Let's do a dump here of the message. This is line 240. Oh yeah, hex dump. Okay, right. So we'll do a hex dump message. We'll dump the message address and the size of message header. We will also dump the control pointer. So that's going to be message.message control. Message.message control one. Okay, those are the two important ones. So let's re-upload that and we'll dump those and see what we get. Don't worry, I'll be asleep again, buddy. That's the spirit. Alright, we got our hex dumps. I'm just gonna kill the let the VM crash and burn. We don't need it anymore. I'm just gonna copy this into Sublime Text window here. So this is gonna be from VM. And we'll get another one from the PS4. Very likely I will have to reboot. So maybe I should get that out of the way now, actually. That way we're good for another test real quick. There we go. There's the panic. That time it triggered on cue. I do actually need to get the p.dump bytes function. I did forget to port that. So I'll just quickly get that out of our previous repo setup. We're looking for userland. Dump byte. There it is. Pretty simple function, but saves us time from having to rewrite it. All right. So in here we're gonna do a p.dump bytes. We'll do a debug log first. Dumping message, and then we'll do p.dump bytes. This is going to be message, and this is going to be 0x20. Is it x20 or hex 30? Right. Let me just check that from here. Yeah, hex 30, and then our dumping control p.dump bytes control, and this is going to be. Let's just get it from here. Hex 3b0 bytes. Perfect. Let's get the PS4 back up and running. Once that's back, we can run our tests and do some comparisons to see where we went wrong. Basically, after that step is done, though, and we get our issues resolved and we get that working, 2/3 of the kernel exploit implementation will be ported. It'll just be the last step. Now, as always, the last step is the bulk of the work. It's probably going to be the most test-heavy stage, the most trial and error stage. But still, 2/3 is good to have done. And considering we're handwriting the Java, like the ROP chains in JavaScript, it's pretty decent. Writing that far. I will quickly touch on earlier. I was getting a bit confused on the C message pointer and the message and how it came before. I think that was just because they're both on the stack. Like if you look at my POC, the the message and the C message are both on the stack. I think that's just the way the stack layout was when it got compiled. Looking at it, I expected it to be different, but I could throw the binary into IDA or whatever, or into Binary Ninja, I should say, because that's what I use as my daily driver. Throw it into Binary Ninja and see what's going on there, but it's not really that important. It was just something that was throwing my brain for a loop. Not worth the effort, I don't think. Probably just an optimization or something. Have you considered just calling the JavaScript functions win get root? I have. Sony blocked them. That reminds me of Teamstar. I don't know if you've always been engaged in the stream when Teamstar joins in, but pretty much every time he joins in, he's like, "Did we get the flag?" It's pretty good. Just CTF life. One day I'll get back into CTFs, try them again. I haven't played at least a time gated CTF in forever. I think the last time I messed with CTF at all was when I dabbled a little bit in CCC's CTF when I went there in 2019. So, been a while. I think DEF CON polls are coming up soonish. Yeah, they should be in around April, right? I think. That's when I remember them being in the past. Speaking of DEF CON, there's no news about the conference this year, if it's going to be virtual again or anything, is there? Has that been confirmed yet? What is this? DEF CON 30? DEF CON 30? No, I don't think it's up to that. Whatever. No, there's nothing that I can see. It's mostly they got the theme and artwork contest, but yeah, nothing on the actual conference yet. Call for everything. Okay. Okay, there we go. DEF CON is planning to perform a risk assessment to help us decide, ideally by sometime in April, if we should hold a physical last known good configuration conference in Las Vegas for 2021. Okay, so it sounds like we'll find out in a couple weeks at least. All right, cool. I think we got a dump from the PS4, right? Did we? I wasn't even really paying attention. I got sidetracked a little bit. Okay, we got a dump. Uh, actually, Control didn't even dump at all. What happened there? Why did Control not dump? Yeah, it didn't dump Control at all, which is worrying. Um, we'll check the message first and foremost. What I'll do here is I'll do a split view so I can kind of look at them both at the same time. This is the message dump. And that's going to be 3, 4, 5, 6, 10, 12, 16. That looks wrong for the size. I have 2 extra bytes. Why do I have 2 extra bytes? There's actually a few things that are a bit weird here, but oh wait, am I just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, that should be valid. Let me just do a quick replace of the 0x0 to 0x00 because that'll help aligning a little bit. Yeah, it was the alignment throwing me off, I think. Because if we account for the alignment, that should bring it more into view. Yeah, okay. It was just the fact that the dump function I have in WebKit doesn't actually do such a pretty representation. It doesn't pad it out, so that's what was throwing me off. All right, let's take a look here. Message and message length is 0, as expected. This is the, let's just get the structure up here. This is going to be the IOV and the IOV length. So this is a valid pointer in both instances. Because in WebKit on PS4, all your heap addresses are going to be are going to have the hex 2 in the upper 64 bits, upper 32 bits. I was thinking we had 128-bit pointers there for a second. Yeah, so the upper 32 bits are going to be hex 2, so that's a valid pointer. Hex 1 is here, that's good. Here we have another pointer for the control, which is good. Control length is hex 804, or sorry, hex 408. And that's hex 408 over there too. Yeah, the message looks good. Next up is the control. Now, like I said, I didn't get a dump of the control buffer. It didn't feel the need to give that to me for some reason. Yeah, really strange that it didn't dump the bytes for me, but maybe we'll try running it again and hope we get it. That is really weird though. I've never had dump bytes just outright refuse to do what I want here before. Right? Because all it's doing is constructing. Yeah, I don't know why it didn't work, but we'll try it again. It might have just been a one-off problem. Alright, there we go. Panic. So we got the peak counter on the ready. I can't imagine they will run it physically. Yeah, I don't think it'll run this year. It would be very optimistic. Um, what's an interesting thought experiment though is I wonder what would happen if they did run it this year. Like how many people would go? Because do are flights shut down between Europe and the US? Like they are like travel between the US and Canada? I would have to imagine they are, but I actually haven't like heard anything about that. But like considering the flight, assuming the flights are not able to like you're not able to land in the US and go through the airport coming from a oh actually maybe you can but you have to isolate or something. Like in either case though, like if you come and then you have to isolate or if you just can't come at all, that's going to massively reduce the amount of people that would be able to fly in anyway unless those restrictions are lifted before the conference happens. So like if you try to look at the or try to speculate on the number of people that would be coming in for the conference even if it did run physically, it'd probably be very sparse. There probably wouldn't be a lot of people there. I don't think flights are shut down. The land border between Canada and the US has been closed, but flying was allowed. So flying is a little bit weird. At one point I know it was totally shut down. Except for like important business related affairs. Um, but I guess maybe more recently it opened up to more general travel from yeah, I think you're right. I think it's from a few locations, like probably like Pearson and a few other airports, but like probably not from all of them. It's really weird. I definitely wouldn't be wanting to charter a flight right now anyway. Flying already sucks as it is. Flying with the current world events would be even worse. I also don't think the um like airline companies or whatever that deal with booking the flights, I don't think they're doing any like isolation measures or not isolation measures, but safe distancing measures. Like I think they still pack you in like sardines in a can. So not an ideal situation regardless, even if you could fly. DEFCON is essential to my well-being. Essential business travel. I'm giving a training and I need the money, so it's essential travel. Well, they pack people in, but the air is changed out pretty quickly on planes. Yeah, but I mean, I don't know if that's really going to help you very much. So again, it seems it's not just a one-off. We cannot dump the control bytes. I do not know why. I'll be honest with you guys. I don't know why. We're in another one of those sections of the stream where I'm just kind of confused because control is definitely a valid buffer. If it wasn't, we would crash in userland on these writes. The length is non-zero. Wait, maybe it's something with the length, actually. Let me step back here for a second. Analyze this function. Nope. I was trying to be charitable, but nope. This doesn't make any sense. Why is it like this? Is it because the dump is too large? Maybe, huh? Maybe we should change it to a lower size. Maybe we're trying to dump too much at once. Oh, actually, you know what? That might be it. I think I have an overflow. I never even really considered it, but how the dump bytes function works is um or how the debug log function works, is it takes the string and it puts it into it does a p.malloc buffer, right? So the debug string is given a hex 1000 p.malloc buffer, and then it goes for the string length and sets the backing to those characters, and then it sets a new line at the end, or a CRLF, and then sends that to mdebug service. What might be a problem, though, is there might be a check inside of mdebug service or something that limits the size of your string that you pass in. Like, it'll probably do like a strn copy or whatever, right? I have looked at mdebug service before, like reverse engineering it, but it's been so long, so I don't remember a lot about it. It's probably got a max length, and if you pass in a length that's too large, it'll error out with like efault or something, probably, or e too big. So yeah, that's likely what's happening. We're trying to print too much at once, and it's erroring out. That's the only thing that makes sense. That's actually almost guaranteed what's happening. So what we'll do is we'll dump, like, I think we can get away with hex 100 bytes. We can just dump hex 100 bytes. We don't need all of them, actually. So that's we'll take it down to hex 100. Because if we do hex 100, that might still be too large. Let's do hex 50. Hex 50 should be within the safe range. Unfortunately, we will probably have to restart again. Yeah, we will. Oh well. PS4 kernel exploitation. What's the end game? What are you trying to achieve by exploiting the kernel? Jailbreak. Because right now we're in the context of WebKit. With WebKit userland code execution, you can't really do anything. You're sandboxed. You're heavily restricted. So yeah, the kernel exploit is basically a privesc to get us out of the sandbox and be able to, patch the kernel and hook the kernel in order to run homebrew and stuff like that. So yeah, that's the main purpose of the kernel exploit. The reason we're doing it on stream is because it's fun. I mean, I say fun. I get mad a lot, and it's frustrating, but it's fun too. Just the world of exploits, I guess. Maybe I should reclassify that. I do always say that exploitation is fun, but I don't think fun is the right word for it. It's really like masochist level shit, You don't really enjoy it that much when you're doing it. It's really frustrating. What you enjoy is when you overcome it. When you overcome the obstacles and you get your end goal. But that's not really the same as enjoying doing it. So yeah. It's like you put yourself through a lot of pain, but then the reward plus the pain makes it worth it. It's a wicked art. Yeah, that's what's cool about exploitation. It's there's like the book, The Art of Exploitation, and that is kind of like a term that got coined too. And people just kind of treat it nonchalantly, but exploitation really is an art. No two circumstances are really alike in exploitation. You are kind of trying to, like, for a particular bug, in many cases, there's multiple ways to get there that are just, like, different people can take different strategies. This bug is actually a testament to that. I'm taking a different strategy than what Slirsgovy and the Flow took, and Slirsgovy took a different strategy initially than what the Flow took as well. This is like the third different way that this bug has been exploited. So, yeah, I mean, it is like an art form. You can get there in different ways. It's a creative task, not a science. Yeah, it's a good way of putting it. Yeah. It's not formulaic. All right, hopefully this time we should get it done. Yeah, I want to get into reverse engineering, but it's off-putting from the get-go. What I would ask there is, why do you want to get into reverse engineering? Because if you're looking to get into it for the sake of exploitation, I would say you might not even need to. Maybe a little bit. Like, it depends on your target, right? If you're working on an open source target, you don't even need to worry about RE. You can just do source review. If you're looking at a black box target or a gray box target, then reverse engineering becomes more important. But like, reverse engineering as a means to an end for exploitation is fairly straightforward. If you're looking to get into reverse engineering for like malware RE and like trying to get around obfuscation and stuff, that is kind of its own area and is a big rabbit hole that you have to go down. Well, RE can still be helpful for crash triaging even with open source. Yeah, it is useful for being able to even just get like type information or being able to see if there's any optimizations that are getting in the way. Like, I've used Binary Ninja for that a few times on these streams, but it's not as important. Like, REing as a means to an end for exploitation is substantially easier than REing like malware or something where you have to deal with obfuscations and packing and all that fun stuff. We did get a dump, so we will now be able to compare that with what we had before. Oh, this is not a good idea. Let's parse it out of a new file so we don't corrupt what we have. All right. Here's our dump right here. So we'll get that in there. Actually, let me get this into a new file too, just so I can do the stuff I was doing before. Get these 0x0s to 0x00. Okay. So our dumps will be a little bit different because in the exploit, we're passing valid FDs, and in the PS4 case, we're passing garbage on purpose. So the control message structure looks like this, right? Just make sure here. Yeah. So we have the length, level, and the type. These should all be the same in both dumps. So that's the first text 10 bytes. So we have 0404. That's good so far. FFFF. That's good as well. 01. Yep. So our header is correct. So this must just be a side effect of sending invalid FDs. I can confirm this. But it is interesting behavior. I would expect it to fail, not just give us a 0 or whatever on failure. It should be setting error node to ebadf, but it's not. I don't know why. Did the VM shut down? No, it's just not SSHing back in. Oh, because okay, it's in a corrupt state. We'll reboot it really quick. While it's rebooting and we're waiting to run another test, I am going to take a quick break just to get some more water. Should be like 5 minutes or less. So Z did design a new challenge screen. For those who have been around for a little while, you may remember we've had little like CTF like challenges on the BRB screen. We finally have a new one. So anybody who's interested in that can take a look and try to solve it. And I will be right back. All right, hello everyone. I'm back. Did anybody take a crack at trying the challenge? I didn't see too much going on in chat around it, so I'm assuming not. But I figured I'd check in. And yeah, I will kind of back what Z's saying in chat there about like where to get started and stuff. Tackling a hard project or just a project in general is a great way of learning. I love doing that too. That's actually how the PS4 started out for me as a target. I was uh, I was investigating it to learn exploitation, so that's how I started out there. No one took a crack at the challenge. All right, all good. We'll probably put it up in the break time challenge channel on our Discord if anyone wants to take a look later on. For those who don't know, we do have a Discord. We send out alerts and stuff when we go live there, and we have our challenges there too. Nah, keep it for next stream. Okay, all right, we'll keep it for next stream. But that said, I will still plug our Discord. People can check that out. All right. So what I wanted to verify was on a VM, those challenges don't grow on trees. These blood, sweat, and tears goes into those challenges. Um, yeah, I wanted to verify if this behavior also happens on the VM. So that's what we're doing now. We'll shift our focus to. File got deleted again. God damn it. Alright, that's fine. We'll put it back up. So basically what I'm going to do here is instead of writing the sendfd array, I'm just going to write dead beef the same way. Alright. Thanks for the advice, guys. I'm going to get going as it's getting late, but good luck on your task. Thanks, dude. Good luck on whatever project you decide to undertake for that. And yeah, like Z said, thanks for stopping by. Always appreciate people coming in and getting involved with chat and stuff. I'm interested in the answer for the challenge. Kind of new, but can help me a lot if you explain it. Okay. Yeah, I mean that's the thing. Like Z said, like we do kind of want chat to work it out. Like we don't want to spoil it in chat. Oh, there you go. Z's willing to spoil it for you through DM. So very good. Do you stream often? It's not consistent. We don't have like a stream schedule outside of the scheduled podcast. We do a weekly podcast on Monday at 3 p.m. Eastern, 12 p.m. Pacific. But these types of streams, like the exploit dev walkthrough, are just kind of impromptu. When we want to do them, kind of thing. Once we're done the PS4 stuff, I think we may stream some other stuff. Maybe not exploit related. I was thinking of maybe streaming some FPGA stuff potentially. Just as on like downtime, just for fun. Like we may stream some other stuff, but we don't have anything planned out yet. These are kind of impromptu streams. What was the challenge? I missed it. I'll quickly show it on stream. I'll go to the BRB screen for a few seconds so you can see the challenge. You can maybe pause or screenshot it. Actually, wait, I have the file. I can just bring up the file. I just need to find it. It's here, I think. Yeah. There we go. That's the challenge. So. Okay, well, I'll drop you a follow on my main account, so if you do stream while I'm active, I can watch. This account's Troll 1, so it'll probably be Alright, all good, dude. That'd be awesome. You were going to troll us? Yeah. So there's the challenge. I'll take it down now so I can run my test, but yeah. Oh, we do have to run it again because the overlap failed. Oh well. Overlap failed again. Wow. Maybe he already did. Responding to you were gonna troll us. Do you post the challenges on a gist? Um, no. We do keep past challenges in the Discord channel we set up that I mentioned earlier. We don't have them on like a pay spin or like a gist or anything like that though. Now I am kind of stupid. I will be honest. I forgot to print out the value, like what send to returned. So I just have to run this test again because I forgot to add one line of code. So that sucks. I might make a website with them eventually. Yeah, that'd be cool. Now I saw the stream pop up in suggestions, and it's not often you see this form of activity. Yeah, it's fun to see exploit stuff. You you do sometimes see like the hack in the box stuff. We've actually rated to people who do that fairly often, like the hack in the box and the what's the other popular one? Got the name of it right now, but yeah, like some of the more real world exploits are sometimes not really covered as often. So, try hack me, yeah, that's right. But yeah, like it's fun to see the real world exploits too. Not to say like the hack in the box stuff isn't interesting on its own as well. It is. Um, but you just don't get to see the exploit stuff on real world targets as often because typically that stuff is kept secret, right? Um, like people aren't going to be working on 0 days or something on stream most of the time unless they're crazy. Um, but where this is like the PS4 is kind of a unique circumstance where because it's an end day and it's actually worth writing an end day for it outside of just the experience of doing it, it does provide that like unique opportunity. But we are approaching 50 hours on a single exploit. Try hack me and hack the box are much quicker. A little bit. Yeah, we put some time into this exploit. This is one of the hardest bugs I've ever seen in kernel. I'd say probably like out of maybe like 10 bugs I've seen that I've really explored in kernel land, this is probably like the hardest one I've seen because of the zone specifics and stuff. Let's see if the file is still here. I don't. Oh, it is still here. Hell yeah. I was gonna say I don't hold out much hope, but it's still here. So, moot point. Nice. Uh, yeah. So what we'll do is down here when we use the write FD, we'll just log what it returns. Right here. So we'll do int temp rv, and we'll do a printf temp or write fb equals 0x lx. We can do a string actually in C pretty easily. So we'll do temp rv and then we'll do str error. There we go. Now we'll be able to see what is actually happening on the VM side with the set of bad file descriptors. All right. Oh, damn. You can see in the VM how we've only ran it a few times. Oh man, did we really? Okay, we did get a result. Okay, good. Yeah, like we only ran the VM a few times, but we've had that overlap fail, and we have to keep rerunning it. On PS4, we're not getting that at all. So the behavior we're getting on the VM compared to the PS4 is definitely different here. Now I will just put this back to do another comparison. But we're definitely getting different behavior. Because on the, you can see right here on the VM, we are getting -1 returned, and we're getting bad file descriptor, which is what I was expecting on PS4. But for whatever reason, on PS4, it's not returning that. It's returning it's returning 0, which I don't fully understand. When did you start to RE the PS4? What did you learn along the way, or did you already have the knowledge to do it? And last question, what was your knowledge when you started? When I started on PS4 stuff, I had some fundamental exploit knowledge. Uh, some of the more beginner knowledge, like I wasn't fully into the heap-based exploits yet. I knew the basics of like stack overflows and heap overflows and stuff like that, but I was fairly early on in what I knew about exploit dev. PS4 was one of the projects that forced me to learn a lot about it. It was one of those catalyst projects. I do not do pen testing. Pen testing's not really in my like circle of interests. I like doing more of the exploit stuff, which pen testing you're working with exploits, but it's more uh like testing if those exploits, like if existing exploits work, or if like software is outdated or that kind of thing. Um Whereas I'm more into the exploit side of things that are used by pen testers, if that kind of makes sense. Like I don't know shit about Metasploit, for example. But if I was a pen tester, I would have to like pretty much breathe Metasploit probably. Um yeah, I mean the data looks the same here. This is really, I don't know why I'm getting different behavior between the two systems. Um in theory, like the code is the same. While Sony has modified the kernel code on the PS4, I don't see their modifications, like why they would modify anything in this code path that would make this happen. Uh, yeah, I'm not sure why I'm getting different behavior here. The different behavior I'm talking about, oh, you guys can already see it. Sometimes I bring this command prompt over so you guys can see it, forgetting that I already have a view set up. But you can see in like the send message should not be returning 0 here. Um, yeah, that doesn't make sense to me. Let me. Are there any other arguments that I might be like missing to send message? Send message. Socket message flags. Socket message flags. Yeah, I don't know why it's not is it maybe the TCP socket pair? Am I not setting that up right maybe? Sock pair AF Unix sock stream. Yeah, I mean that's correct. Hmm. I'm not sure what's happening on that one. I'm not sure why we're seeing wildly different return values with the same data and the same arguments. Right FD. and our write FD over here. So this is sending to a TCP socket. The message is a stack buffer, which we don't use. We use a heap buffer, but that's essentially the same thing to the kernel. It'll read whatever we set up there. Maybe are our offsets off? Maybe that might explain it if our offsets were bad. I love getting into as much as I can, but I love red teaming. That's my goal generally. Yeah, red teaming's fun. It's where my wheelhouse is. And for the language, what was your background at the time? Knew C and used it for many years, or just an IT student? Basics, a few languages. I was pretty comfortable with C, and I was fairly new to assembly, but I was comfortable with most assembly, like the common instructions. But yeah, like C, I was already pretty familiar with. Now, I don't know if I'd ever say like I'm an expert C programmer or something. I do use C quite a bit, but mostly in the context of exploits. I'm not writing like production grade software or anything in C, so. But I'm like pretty comfortable with it, and I was when I started the PS4 stuff. Um, yeah, somebody asked about a GUI for generating PS4 packages. And Alizif, what Alizif put in there is exactly what you want. It's Maxsense tool, liborbis package. It's a C# based tool. It's really useful. Um, and by this point, I think he's made a lot of improvements and bug fixes since the original release. So yeah, that's pretty much your go-to. Um, and in regards to Orbis PubGen, I mean the biggest problem with that is that's the official SDK tool. It's not open source, and you're technically not supposed to have it unless you're a developer who signed an NDA. So that's the biggest thing with Maxens. It's what we use with the SDK, with the Open Orbis SDK, for compiling samples and stuff. We actually bundle liborbis liborbis package in the release packages for the SDK. It's a really awesome tool that he worked on. Um, yeah, so I'm gonna have to verify the offsets, I think, because I think an offset must be wrong. What I think I will do to do that is I'm gonna open up Binary Ninja, I think. Or actually, no. You know what? I'll run. I already have VM running, so I might as well just modify the code to print out the offsets. Um, so in here we'll do control or message control equals yeah, LX, and then we're going to use the offset of. Offset of does that come from a header? I don't remember. I think this is a compiler thing, but maybe no. Okay. It's a C macro. It's in the standard def header, I think. All right, so we will need that. Do we have that already? No, we don't. Okay. All right, now we can use offset of. Offset of message.message control. And I just want to get all the relevant offsets for what we do. Maybe my head math was wrong for one of them. Well, name and namelen are impossible to mess up, so get rid of that. It's got to be the control one. If we're messing anything up, it's the control header, I think. We can print out the IOV and IOV length too, but I think if that were failing, we'd be getting a different error. But I'll do it since it's only 1 or 2 more lines anyway. And that's going to be IOV len. You know what? We can print out the size too. Size of message. Okay. Oh shit. Okay, that's not good. Offset of undeclared. What? I mean, I thought it was in standard def. Oh. Wait, I'm calling it wrong. I gotta call it like message HDR or struct message DR, and then message control. Yeah, I forgot the way that it worked there. I thought you just passed the direct offset, but you don't. So there's gonna be control len, OV, okay. This should hopefully work. Oh no 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 no! Do not run that shit. I think I canceled it at the time. There we go. Basically a tool called GDB, or you can install GDB PETA to make GDB simpler to use. PETA is nice. It is pretty dated by this point. It's not maintained anymore. All the cool kids have moved on to. Well, I think there's something new now. Is it Jeff? JEF? I don't remember. GEF, yeah. That's where all the cool kids are at now. Connection reset by peer. I think that's fine. We should be able to get the offsets that we wanted. Maybe. Okay, I'm gonna have to copy this into a buffer. Let's see. Oh, that's definitely not what I wanted. Offset or app message. You know what? It's actually not giving me what I want. I don't know why, but it's not giving me what I want. I think it's because it. Yeah, I don't know why. Let's try just clearing and trying again. I'm not sure what happened there. No, it's still giving me the same problem with Okay, there we go. Should hopefully work, right? Oh my god, I'm so stupid. This was on the wrong thing. I meant to do it on the write FD, not the read FD. Ah, that was really dumb. Okay. Well, now I know why I wasn't getting it, at least. I might have gotten it for the read, but I don't think the read would have executed. Oh, it did execute. Nice. Okay, well. Worked out in the end. I use Maxton's F package repackaging GUI and I experienced many issues with it. You could try using the version we ship in the SDK. It is a bit older, but I know it works because I built the samples with it, so. I don't remember the exact version we had in the SDK, but you can get the SDK release and use that one. I'm heading out, but nice stream. Keep it up. Thank you, BeastFN. Thanks for stopping by, dude. Okay, let's verify our offsets. Make sure they're correct. Because I have a feeling they're not. Okay, control is at hex 20. Well, that's what I have. Control length hex 28, IOV hex 10, IOV len hex 18. Yeah, okay, wow, our offsets are fine. So it's not even like, are our sizes wrong maybe? So hex 20 is control. That should be good. Oh, this is... No, that should be fine, actually. Control should be fine. Uh... Control length at hex 28, and it's valid control length. Oh, wait. No, it's not a valid control length. We're specifying hex 408. That's wrong. Oh, no, wait, sorry. Hex 28 is the offset. No, that should be right. Then why are we having problems, dude? The offsets are good, and my data is good. What the fuck? Okay. I don't know why it's not failing when I'm sending bad file descriptors. Something I could try is I'm probably going to move this up above the double free, and I'm going to test a few things to see if we can pass like file descriptors properly. So I'll do that at like the very top, basically. Because I shouldn't depend on any of this shit. So this should be fine. We'll do an early return, that way we don't have to reboot the test every time. Oh, you know what, actually we will have to, we are going to depend on some of that. Because we have to have the TCP socket pairs working. So we'll have to go lower. TCP socket pairs, I think, is set up here-ish. Yeah, here. Okay. So right above the trigger for the double free is where we can test. 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 Return. Okay. So this is going to be right FD. So here, we're going to pass a stack of valid file pointers. So we're going to have to open a bunch of valid file pointers, obviously, in order to do that. Let me copy the call we already have as well. Oops, wrong spot. Right here. So TCP sock pairs, that gets opened up here. Very good. Okay. So when we create an array of FDs, we have to make these valid descriptors. And we're going to open 253 of them. So we're going to do a chain.syscall, window.syscall names, sys open. Now we do have one slight problem here. We do have to open valid, like we have to open a valid file inside of the sandbox. What I might do is I'll just see what Slears Govey opened and save myself the trouble here. Yeah, he just opens up the... Oh, that's smart. Right, okay. So what he does is he constructs the path to the libkernel library, and then he calls the randomized path syscall, which is a Sony provided syscall. What this does is it returns the sandbox ID, because for those who haven't looked in the PS4 sandbox, the root directory has a directory inside of it that contains like the common stuff, but it's always a UUID. It's not going to be the same every time. So the way you get that UUID is by calling that randomized path syscall that Sony has set up. So basically what he does is he constructs the path and then he overwrites that path with the with what he gets from the randomized path syscall. Okay, that's a bit more work than I was hoping to kind of put into it. But hey, I mean, it works, right? I wonder, can you pass things other than files? And will it work the same way? Like, could you pass socket descriptors? That'd be wild. I don't think you could do that. But maybe you can. I kind of want to look at the code. Because that would actually be... that'd be a good idea if we could just pass socket descriptors, because it means we have more... It's going to be longer before we hit the limit. Does it check the type on the files you pass? Oh, it has to have this deflag passable flag set on it, which sockets might not. They probably don't allow you to pass sockets around. Let's find out. Okay, so a pipe is passable. Shared memory is obviously passable. You need that to be passable. A process descriptor is passable. File is, of course. Pseudo-terminal is. Oh, a socket is passable. Oh shit. Okay, we could just pass sockets then. Right? That's kind of... I'm surprised he opens files that way if you can just pass sockets, because then... Like, I'll just pass the sockets I already have opened, right? That saves a lot of work. Instead of doing this, I can just do... Well, I should have kept the for loop, but I can just do fds I equals UDP spray socket UDP I. And then I can just pass the socket. Yeah, that's like way easier, I think. We do need to read on the other end to make sure we can actually receive them again. So we'll have to set up a read FD too. And we need to do this anyway for the third part of the exploit, so we might as well get that out of the way now. So we got write FD, we need read FD. And that's going to be called on the second socket in the pair. So let me get this up on another screen, and we'll work on porting this as well. Get that out of the way. So key.readFD function TCP sock address size FDs. Actually, we can just remove this part, because in JavaScript we can just make it return the array directly. That'll probably be simpler. All right. So just like the write and the read, or just like the write and the read, in the read, just like the write, we're dealing with the same types of structures. So get the comment copied into there as well. Now, you know what? I was originally saying we should probably keep these out of the function, but the more I think about it, it would make sense to do it inside the function. It helps to make sure that nothing gets smashed by the other function. So move this below the comment. Okay. We'll let the scope take care of everything for us. Next thing we're going to do is we do have to set up the control or the message to receive again. So we're gonna do. Actually, we'll copy what we already have here for the IOV because the IOV is gonna be the same. The message is also gonna be the same, I think. Message name length IOV. Yeah, this is all going to be the same. The only difference is we don't have to set up the control header ourselves because we're going to be reading that in. So we'll get this in there, and then we're going to do a chain.call window.syscall names this RESTv message. And to call RESTv message, we've got to pass the TCP sock or the socket descriptor. We got to pass in the address of where we want the message or what message information we need, and 0 is going to be the flags. Then when we do that, we should probably check this as well. Our RESTv fd debug log RESTv. And then actually we'll just do a dump bytes of what we get out of the message. So we'll do a dump of message and we'll do it for hex 50 bytes again. Okay. Should be good to give this a spin. See what happens. Good thing is with this, since we're not triggering the double free, we should be able to run tests in succession without rebooting. Is it me or is the chat extremely silent? It is kind of silent. I think it's partially the day and time, right? It's Sunday and it's a bit late, so I'm not too surprised. I used a new one yesterday to make an F package from one of my disks. The only thing I needed to do outside of it was use make f self. Use the latest make f self. Okay. Viewers are just entranced by the content. Yeah, we'll go with that. Because we're all confused, what is this code is all about, but keep watching anyway. Yeah, I mean, doing a full breakdown of the exploit at this point would take a while. But we're writing an exploit for a bug, and that bug can be linked to from the bot by using the bug command. There you go. And reporting the POC that somebody just put in chat as well. Wait, where am I? Who are you? Yeah, exactly. I don't know who I am either. It's one of those days. Sometimes I don't know what I'm doing here when I observe some of the behavior that I get from the PS4 and from BSD, to be honest. Again, for the read FD, we're gonna pass garbage, 1 byte, and we're gonna specify we'll specify a different FD array, out FDs. Now, actually, I forgot. We modified this so that we get the out FDs that way. Our out FDs. Right, and then we'll do a iteration. Although, actually, this doesn't matter at this point because I'm not parsing them out, so... Yeah, this doesn't even matter. I'm wasting my time worrying about that right now. That's something we can circle back to later. Okay. System was in a bad state. I didn't realize it panicked. So we gotta reboot the system. Get a few more beeps in. Alright, once PS4 is rebooted, we're gonna give this code a shot and see if the write FD and the read FD are working as they should be. I do have my doubts because write FD wasn't operating the way it should have been with the bad file descriptors. But maybe with good file descriptors, it'll behave the way we expect. I don't know. We'll see, I suppose. We shall see. I think the PS4 still has to do its secondary reboot here real quick. Then we'll be able to test. I will check the display, though. See if I'm wrong. But yeah, no, ICC reboot. Yeah, we gotta wait. We will see if you're wrong, chat riots. Pitchforks out. Alright, PS4 is rebooted. We'll be able to test if the write FD works properly. What the? No, actually, we won't. What the hell just happened? System just died. Ghost53574, thank you for the tier 1 sub, dude. Welcome in. Now you can riot. I didn't even notice he turned on subscriber only mode for a few seconds there.